In this lesson, we're going to investigate the ambiguous case of the sine law. And what the ambiguous case of the sine law means is that when we use the sine law to find an angle measure, there might be another angle that we also need to include in our answer. So that is, there may be two or one possible answers. Now, there are situations where you'll be given measurements for a triangle where there is no possible triangle that you could create given those measurements. But we're going to focus on just the ones that actually come up with a valid angle measure. And we'll deal with the possibility of there being two answers and just one single answer. And how do we tell that? Okay, here's a question that involves the ambiguous case of the sine law. And it says, find all possible values for angle A in the triangle with angle B is equal to 33 degrees, side A 27 and side B 22. So how do I know this is the ambiguous case? Well, the first clue is when you are given a phrase such as find all possible values. Well, there's a big clue that there might be more than one unique answer. The other clue is this. I'm given an acute angle right here and its associated side length. So I got angle B and I also have side length for B. And then I'm given only one other side, in this case, side length of A. When I'm given that particular setup, I know that I need to be careful about the ambiguous case for the sine law. All right, so let's do a sketch, and we'll go ahead and we will draw this triangle, and then we'll see how we can solve it and see if this is in fact an ambiguous case situation. So the first thing I'm going to do is just draw a triangle, okay? And the corner in the lower left-hand corner, and I draw the triangle in a very specific manner, I'm going to label this here, angle B. This is going to be the angle on the left. So this will be my 33-degree angle. That makes this side, side B, and it has a length of 22. Okay. The next side, which is this side here, A equals 27, I'm going to place on the top side here. Doing that makes this vertice A, and this leaves me with vertice C here and little c here. Okay, so we need to solve for angle A, that is this measure in here, and we're going to use the sine law to do that, and you can see that we do have a complete pair right here. We have an angle and its associated side, and then the other pair that I'm going to use for the sine law will be the A and this side length here. So I have two complete measurements, and that means that I can write the ratio of sine A, I'll put the angle on top to make it easy to solve, over 27 equals sine of 33 degrees over side B, which is 22. With one step, I can isolate sine A, so I'll just move the 27 over to the other side, and it will be 27 times the sine of 33 degrees, all of that divided by 22. The angle A, well, I'm just going to do a little bit of calculator work here, and it is going to be the inverse sine of this right side. Okay, and when I evaluate this on the calculator, I'm going to do it all at once to get the answer for A. Okay, so here's our calculator, and we'll go ahead and evaluate this. Second function sine gives me the inverse sine of 27 times the sine of 33 degrees, and we're going to divide that by 22. Okay, hitting enter gives us a value of 41.945. 41.945. So 41.945 is the measure of angle A, and we're just going to round that to 42 degrees, and that will be angle A. Now, in this situation, we need to make sure that there isn't another possible solution. And we're going to take angle A, and that's our first solution. And now we're going to check for a second possible solution. And how do we do that? Well, all we're going to do is we're going to take 180 degrees and we're going to subtract that 42 that we just solved. Okay? And that gives me a possible answer. And that means that we're in 138 degrees is a possible solution. And where that angle would be is, take a look at the diagram for just a minute. If I drew another side on the triangle, in fact, if I took this line here from C to A, and I actually swung it over here, so that my new triangle went up to here, down there, and over to there. There's the other possible way of drawing this triangle. And this angle of 138 degrees is this angle measure in here. Okay, now why is it 180 minus 42? Well, simply because these two side lengths right here and right here, well, they're the same side. They're side B, 22. I've just moved this side over to here. So that means that this angle here is also this angle here. Okay, so because a straight line is 180 degrees, 180 minus our 42 gives me 138. Okay, so how do we check if 138 is okay or not? Well, all we do is this. We know that angle B was 33 degrees. Okay, that was the measure of angle B that we were told is in the triangle. Well, to that measure, I'm going to add this 138 degrees. Okay, and this is the other possible value for angle A. I'll call it A primed. Well, what is that total? Well, let's see. 8 and 3 is 11, and 3 and 3 is 6, plus 1 is 7, and 1. Now, that gives me a total of 171 degrees. And that's terrific because it's less than 180 degrees. Okay? That means that this angle in here, right there, angle C, that would be equal to 9 degrees. So there is room, I'll just put here, for angle C. And in fact, angle C would be 9 degrees. Okay, so because we could construct a valid triangle with this other possible angle of 138 degrees, then there are two solutions to this question. Okay, so the solution, well, angle A equals 42 degrees, or angle A equals 138 degrees. And the reason why it's called the ambiguous case is with the information given, there's no way to tell which one of those answers is preferred or which one is the quote-unquote correct answer. They are both equally valid. So the choice of which one is the right one is ambiguous. You can't tell. Okay? So that's the process that you go through when you check for a second possible solution. We just take 180 degrees, subtract it from our first answer, and we have a possible answer. It's only proven to be a valid answer when we actually prove that we can produce a triangle containing that angle. Okay? Well, let's look at a second example. Okay, in this second example, I won't take as much time with the preliminary work. We'll just go ahead and draw the triangle and solve it. And we'll see if we can come up with, again, the ambiguous case and see if there are two valid answers that would apply in this situation. So I'm just going to quickly draw the triangle. So we'll go ahead and draw it in the same manner as before. I'm going to label this lower corner. In this case, I'm given angle C. So that is the measure that I will put right there, 63 degrees. Little c is going to be 12. I'm going to place the other side, B, on this, and that will put angle B here and angle A at the top. Okay? All right, so very quickly, we're solving for angle B right here. So I will say, all right, the sine of B over 9 will equal the sine of 63 degrees over 12. Isolating sine B, I will move 9 up with the sine of 63, and then solving for B, I will take the inverse sine of this value over 12, and that will leave me with an angle measure for angle B that is equal to. So using a calculator, we can just evaluate this expression. I'm looking for the inverse sine, 9 times the sine of 63 divided by 12 equals, and we get 41.9325. 41.9325. We'll just round that up, and we'll get B is equal to 42 degrees. So our first answer is B equals 42 degrees, and we're guaranteed that that is correct. That's one of the answers. In fact, that matches the triangle that I just drew. Now we need to check for a second. Okay, so check for a second case, the ambiguous case. So remember our technique. We're going to take 180 degrees. We are going to subtract 42 from that, and we're going to get an answer. Okay, so when I do that, I get, again, 138 degrees. All right, so what do we do with that? Well, now I need to check to make sure that I can create a triangle with this new 138 answer. So what do? Well, I take the 63, which was the original measurement of C. To that 63, I'm going to add 138 degrees, which is the second possible answer. And I get, well, this is troubling because I get 201 degrees. And since this is greater than 180 degrees, it is not a possible solution. Okay? So that means that the only answer, in this case, the solution is angle B equals 42 degrees. And that's it. There is not another angle in this case. So in this case, it looked like we were going to get into the ambiguous case problem, but once we got the solution out, I checked for a possible second case, and there is no possible way of creating another triangle with an angle other than 42 degrees in the corner, the vertice that is B. So in this case, there's only one answer. So you have two examples, one where there were two possible solutions to the triangle and one where there's one. The process is exactly the same in both of them. You just need to make sure that you always check that second answer to make sure that it's less than 180 degrees when it's added to the original angle, and you can actually create a triangle using that possibility.